Okay, I think we should be good. So, good morning, everyone. Welcome to AI Saturdays Lagos, Week 2 Research Cohort. My name is Tejumade Afonja. And for today, we will be going through the research process from idea to publication. You can scan the QR code to get up to speed about the program of the cohort. And I'm very excited to introduce our speaker, Orevaoghene Ahia. Oreva is a PhD student in computer science and engineering at the University of Washington, advised by Noah and Yulia. Her research involves developing practical language technologies that are fair, reliable, and adaptive to diverse users, language varieties, and data modalities. To achieve this, Oreva's work has addressed several areas. This includes developing robust frameworks for curating resources for diverse languages and varieties across different modalities. It also includes auditing multilingual language models and data to identify and mitigate harmful biases. In addition, she has worked on designing model architectures that efficiently learn representations to overcome biases and existing limitations in current multilingual language models. So without further ado, please join me in welcoming Oreva to today's workshop topic. Oreva, the floor is yours. As soon as you would like to, please start sharing your screen.
Hi, thank you so much for the introduction. Yeah, Tejumade is introducing me like she just met me. Yeah, but we go way back, like way back from like the ghetto back. Yeah, so I'll just try to share my screen now. Um, just a sec. Um, so yeah, let me know if you can see my screen. Okay, awesome. Yeah, so thank you so much for inviting me to talk about some of the things I think I know. I guess a lot of things I'm talking about will mostly be from my experience. So like Tejumade said, and I don't know if like what the format is, if like people can ask questions during the talk or yeah, feel free to stop me. I don't know
Um,
if
if you don't mind, we have budgeted like a QA session
Oh,
after.
okay, then that's great.
Okay, so we can
Then
take questions after the talk if it's not very urgent. Otherwise, we can
yeah,
also
sure.
do it while we're talking.
Sure, that's great. Yeah, so I'll be talking about the research process from ideation to publication. So like Tejumade said, my name is Oreva Ahia. Um, a few things about me. I'm a fourth-year PhD student at University of Washington, here in Seattle. I work on a couple of things. I've worked heavily on multilingual language models. I've worked on tokenization. Very recently, I've been working on evaluation and alignment of multimodal models trained on speech and text. Yeah, I don't know why I included this here, but I love music a lot. Yeah, I insanely love music. Um, and I'm very happy and excited to be giving this talk. And like I said before, like all of these things are like just based on my experiences, based on things I've heard and read from people. So yeah, just filter out what would work for you and what might not work for you. Okay. Yeah, so the talk outline. Yeah, this is exactly what I was given, to be honest. And when I started my PhD, we had this class called the Tower of a PhD. It's typically how to do a PhD. That's the name of the course. And each of these things were like single like topics that we treated each week, like in 1 week. So one topic per week. Yeah. And so I tried my best to, just bring everything together. So we're talking about like, how to decide how to choose research topics to work on, how to choose advisors, um, for like, grad students or prospective grad students or mentors, and also, how to, transform ideas into publications, and also how to present your ideas. And I guess finally the highs and lows of doing research. Yeah. So choosing research topics, I will start with this. I don't know. I was, reading like materials, like trying to prepare for this talk. I'm trying to decide like, what to say. And I stumbled on this resource that had this quote from this professor Irielon that works on computational biology, which is not like very relevant. But yeah, so I guess like he was saying that, it's very important for researchers to choose good problems. But how do you decide what a good problem is? And how does this, how does scientists even choose a good problem to start with? Um, so yeah, so this is something that's not like usually discussed as a scientist. Sometimes you're just expected to be so smart that you come up with like incredible ideas and you figure it out by yourself or, by just like, like through mentorship. But the fact that, you know, sometimes as researchers, like, or even as independent researchers, sometimes like if you're not like, taught, if you're not mentored well, it could kind of like hinder, how much progress you can make in your research career. So if you don't know how to, come up with good problems or how to like work on good problems, yeah, it could, hinder, how much progress you make in your career. Um, so, so the goal of research, right, is to, solve problems, is to create knowledge, right? To create knowledge on how to like, solve problems, to solve problems in general. And the world has many challenging problems to work on. I mean, I feel like a lot of problems, fall within this, SDG goals. That's why I put it here. And some of these problems can be solved through like technological advancements, some not necessarily. Um, but as a researcher, you usually would have like limited time or bandwidth. Like there's only a handful of projects that you could work on per time. Really. So it's important to develop good taste in selecting impactful topics to work on, impactful problems to work on. And one thing to note is that, no one is born with like good or bad taste in research, right? Like you don't just automatically become like good at selecting good problems or good at, solving problems. Like you develop taste, you learn how to do things better through exposure to different opportunities and experiences through like, working, through mentorship, through yeah, exposure basically, to be honest. So yeah, so it's totally fine if like, starting as a researcher, you feel like, oh yeah, my problems are not like, very cool, or like problems I'm solving, or my ideas are not like very cool. People don't care about my ideas. Like it's totally fine. Yeah, like everybody like, starts from there. So how does one cultivate like a good research taste? How do you choose interesting things to work on? So I'll give like some like very like, superficial like overview of, how, this works, and I would now go ahead and talk about like what to look at when you pick problems to work on, or how to select good problems. Um, so first of all, like to cultivate researchers, like it's good to seek out people like researchers with good taste. And how do you go about this? One, so I would say research communities first before mentorship, because at least like at some point in my life, I was like an independent researcher. And to be honest, like research communities helped me a lot to grow as a researcher then. Um, so in research communities, sometimes you can identify like more senior researchers that can now either like mentor you or give you feedback on like, ideas on topics you work on, and even like, just being like inspired. Like I see some papers that some people put out and I'm just like, inspired, like, how did you even like think of this problem, right? So sometimes just like being, um, sometimes just like even being like around good researchers, that also like influences how you like select problems. Like even like in the PhD, like sometimes like I have friends that like work on like very like incredible things and they're giving talks and I'm just like, oh my God, wow, like this is so like incredible. This is, so brilliant. Right. I mean, it doesn't like like mean that like, it directly transfers, but you just like, also like want to be like that. So I mean, this is, not, I mean, so like sometimes like good problems, you find good problems in like conference proceedings, but to be honest, like the review process for for conferences is very random. So like not everything that's accepted is like seemingly good or seemingly important. But sometimes like good you could get good signals from papers that win awards, like best paper awards. They have like different categories in conferences. So sometimes it gives you like, a glimpse into, what you should be working on, where the future is going, what the community cares about. And all of these are just like, very superficial. And also finally, like, sampling and experimenting with ideas, like you don't get better at something if you don't like, try to like get your hands dirty, right? So like implementing existing ideas, what people have done before, right? And trying to like challenge the status quo of existing methods. Like, why does this work this way? Why is it transform architecture built this way? Yeah, things like that, like, help you. And yeah, I think the other thing is like to keep a list of ideas. And honestly, like it's fine, like as you start out, if ideas like you think, oh, your ideas are not great, it's fine. Like just write them down. Um, with time, like you start to like connect dots. Like I write like ideas down like almost every day. Sometimes like they're like really like terrible ideas. Or I think they're terrible ideas. And I talk to my mentors or my advisors and they're like, oh, like, that's really brilliant. Sometimes they're ambitious ideas, sometimes like they're not realistic, but it's fine. Like as soon as you think about it, just write it down. Think about like, oh, like one way to like, what's this idea about? What's the problem? What are you solving? Blah, blah, blah. And then talk to people, like talk to people about your ideas. Honestly, that's how you know if your ideas are good. If you just keep them to yourself and just work on them, I mean, maybe nobody would care eventually, but talk to people about your ideas, like hear what they think. Like, are they excited about it? What feedback do they have? Um, so this also is still like, still like general stuff, but like very important. Um, and yeah, I know everybody wants to hear about like, how to select good topics, but good topics to work on. But I think this is also like very important to flourish in research. So one of the barriers to flourishing in research, at least like computer science research, is, technical knowledge gap. Um, really. And this would like, prevent you from, first of all, like understanding existing methods, like understanding papers, right? You have a paper, and then, I mean, you probably have an idea of what they're doing, but if you do not know what's going on there, then you probably cannot even improve on it, right? So, I mean, there are like some ML foundations, foundational knowledge that could help with this. And there are different kind of papers. Some papers are like, very theoretical, where like you probably need like some knowledge of calculus, linear algebra, and yeah, what's the other one? Probes and stats to understand them. Sometimes some papers are not like very theoretical, so like they could be a bit easy to understand, but maybe like you need to have like, read some literature like in that area before understanding them. Also like being able to like code, I guess like being able to, because if you can't like code, I'm not like, software engineering, meta, Google, like software engineer, like level kind of like, coding, just being able to like, reproduce with experiments, like implement stuff and, improve them. Um, Another thing is always working on incremental problems. Honestly, like starting out as a researcher, it's fine if one works on like incremental problems, low-hanging fruits. But you don't want like your entire career to be built on top of like, just incremental problems. Incremental problems are just like, we just want to um increase the accuracy by like a tiny bit. Yeah, so you have to like think of other things. So if you're increasing the accuracy by just like, 1 point, okay, is the model like more efficient, right? Or, are you just, trying to reinvent the wheel? Another big issue is, lack of computational resources to execute experiments. That's like, I mean, I guess it depends on what kind of research you're doing. So if you're doing research that requires you to pre-train models, then yeah, this could be a barrier. But yeah, inference time experiments or inference time like projects that people work on that just require you to be able to, load the model and, do inference. Then good mentorship too. Like this is, if you're working, if you're a PhD student, for instance, right? Like if you don't have a good mentor, like a good advisor, then things could go south, like your progress could be stalled. So usually when people like, fall into the hands of bad advisors, they try to like, change, find new people and all of that. Okay. Yeah. So now let's talk about like how to come up with good topics. So I mean, the title here is like focus on finding a problem and not a solution. And I would say why. So take for instance, you just say out of the blues, I want to build a retrieval augmented language model. Um, right. And a retrieval augmented language model is just a language model. I mean, it's just a language model, but then you're feeding in, like, you're retrieving like some knowledge from like some external like data source and using this to augment like information that the model already knows, right? So for instance, if you ask the model, oh, what's the capital of Nigeria? And you probably did not see that in trained data, you could, retrieve some data from like Wikipedia on Nigeria, like some Nigeria document, and then feed that into the language model, and it's probably able to like, perform. So you can say, I want to build a retrieval language model, or you could say, or retrieval augmented LM, or you could say, I want to build an agent that is RL. Yeah, but why? Like, why do you want to build this? Um, so you can't like really do impactful research by just vague goals like this, right? I just want to do this. I mean, sometimes it's fine, like if you're starting out, like just trying to work on projects, right? But for research, it's usually important to find issues that the research community would care about and then work from there. So find the problem that people care about and then work towards finding a solution. So for instance, let's say language models are bad at solving certain math problems. So that's a problem on its own, right? Right, that's the problem. Then we ask why. Why are language models bad at solving certain math problems? Then maybe we identify like two issues. So maybe language models are bad at solving math problems, certain math problems, because these math problems require like reasoning, and language models are potentially bad at reasoning in general without like, extra like, prompting techniques. Or let's say language models are bad at segmenting numbers. They are bad at learning like good representations for numbers, right? So we've identified like a problem, and we've identified like two sub-problems under this, right? This is like the first problem, and then this is why like language models are bad at solving math problems, right? So now that we have this problem, we can now design a solution. We can now try to find a solution. So how do we help language models reason better? Or how do we improve segmentation of numbers in language models, right? So that now becomes like the goal, like our goal, right? Whereas before we just said, oh, I want to build an agent that uses RL. What solution, like to solve what? So when like after you've identified your problem, you now want to experiment with solutions, right? So the thing about finding a problem is that you're not tied to a solution. Like you will do everything to find the optimal solutions for a problem. So you could go from, oh, like how have people approached this problem? Yeah. And obviously, and of course, you also want to work on problems that people care about. Like, I mean, sometimes it's okay to like, go like, some step further from like where like the hype is and all of that, but you don't want to go too far away from the community if not like nobody's going to read your paper. So like how people approach this problem. And so why did their methods not work? That's a question you want to ask. So read their papers, identify flaws, what are they doing wrong? And what can I do better? Like how else do I approach this problem? How else can I solve this? So people have proposed multiple solutions, but they still don't work. And I want to propose like a new solution. Yeah, so for instance, like a solution to reasoning that people have, proposed is chain of thought prompting, where you teach the model to compartmentalize the solution and, um solve the problem with like very like small steps before it like, reaches the eventual goal, right? So this could be like a solution to the problem of how to make language models reason like over problems better. And there are multiple solutions that people have proposed based on like domains, but this is just an example of, what a final solution could look like, right? And in this case now, like they're comparing like standard prompting to chain of thought prompting, which is a potential solution. So heuristics for coming up with research ideas, right? So I've mentioned this. I said your filters on important problems, right? And important problems, problems that like it's like, problems that like are within, things that like people care about in the community, right? Also like, investigating failures and flaws in existing work, like challenging like existing work, like why does this work, right? Like how could it, like what are the flaws? How could it be better? Also like, trying to find analogies between existing work and, open problems. There are lots of open problems. Some of the ways people actually even find problems these days with like language models is just like testing them on like random like tasks, really. Yeah, like just testing them on like random tasks, and then they find that like, oh yeah, models like are really bad at solving these tasks, and they try like, a couple of other models, yeah, and then they start to like, experiment with like different like solution, like potential solutions. So I take away from this is you want to find a problem before a solution, because if you have a problem that you're not emotionally attached to any particular solution, you will always like settle for like the most optimal way to solve the problem. But if you have a solution before a problem, if you say like you just want to build a language model, an agent that uses RL, then your solution is just too narrow, and you now have to start looking for problem for your solution, which is like never a good way to go about research, to be honest. Because yeah, you might find a problem to your solution, but maybe people have like better solutions to solve that problem. Also, I mean, people might not read your work. Yeah, your solutions will be too narrow, like I mentioned. So now we've talked about, like how to choose problems or how to identify problems to work on. And yeah, I'll just go ahead to talk about like how to choose advisors and mentors. So some of the things I would say here would be um more for like, prospective grad students, so people that want to, go to grad school, but not everybody has to go to grad school to do research. So this could also apply to like, seeking out mentors, right? So sometimes, at least even before, like to get like, research experience before grad school, before applying to grad school, sometimes people like cold mail professors or cold mail like researchers that they want to work with. And to be honest, like sometimes they would respond to you, to be honest, and want to like talk to you or potentially work with you, potentially mentor you. Yeah. But anyways, the first like important thing is to at least ensure that you have like some overlap in research interest. This is very important because if there's no overlap in what you want to work on or what you care about and what they like work on, then you would not receive like very good mentorship in that aspect. Like you wouldn't receive like very good feedback. So they wouldn't be very useful on your project. They wouldn't be very helpful. But in some situations, it's totally okay if you're starting out. So for instance, if you wanted to branch into a new area, right? So if you're starting out, like, maybe you used to work on computer vision before and you want to start to work on natural language processing, right? So it's fine if like your previous research interests do not like directly align with like what your prospective advisor would work on. So sometimes you could learn, right? So that's like typically fine. In some cases, and sometimes what people would do is like they probably would just have like, like two advisors, like in grad school, for instance, like two advisors. So one advisor that's like, aligns with your research interest and just maybe like some external one that just like, brings in some other domain expertise. So overlap in research interest is like very good. Then also advising technique and what works for you. Because it's like very like when one is like trying to get into grad school and applying, like it's really frustrating to be honest. You're just like, anywhere, like anybody that takes me, I'm just gonna go there, right? But sometimes it ends up like, good, but people like, end up in like really bad, terrible situations just because the advising technique of the professor, doesn't like, match with, or the mentor doesn't match with like, what they could work with. So for instance, like, do you have compatible working styles? So there are two different kinds of mentorship. Probably there's something in between, but like there are professors or mentors that are like hands-off and there are professors that are hands-on. Um, so hands-off professors are professors that, let you do lots of things independently. So come up with your research ideas. A lot of times they would not, yeah. So hands like come up with your research ideas, come up with solutions. They would help you brainstorm. Sometimes they would give you feedback on your ideas, usually, but a lot of times, like the ideation process is just like, solely you. And there are hands-on professors that like, like literally just hold your hand, right? Like give you like problems to work on that would some of them would actually even like, you know, look at like help you debug your code and all of that. Yeah, I have two professors that are both hands-off. And there are pros and cons, like, with like hands-off and hands-on mentors, right? With hands-off mentors, like you develop like, independence like very early on, right? But it also means that sometimes like progress might be stalled just because like it's just you that's coming up with stuff and they're just like, helping you like to refine your ideas. But with like hands-on mentorship, sometimes like you might just like, push out things like fast. But I think that honestly, like even with like hands-on mentorship, like eventually you start to develop like new ideas, right? But you might just like be like kind of like dependent on your professors for like just a little bit. So also you want to know if they are supportive, like talk to their students or talk to people that have worked with them. Like, are they happy? Did they have like any bad experiences? Academic credentials, right? So you can add like you always have like senior junior advisors, right? And these also like have their pros and cons. Senior advisors are usually like, full professors. Junior advisors are usually like, very new assistant professors. And it has the pros and cons. Senior advisors are usually more hands-off, most of the time. There are some senior advisors that are hands-on. But junior advisors are usually like very, very hands-on because like most of the time they are fresh out of grad school, they're fresh out of a postdoc, they have like, lots of ideas, they have lots of things to do. Yeah, so there are pros and cons, like you literally just, pick your poison. Um, Also managing expectations. Yeah, sometimes it's hard to like, know this from the outside, but this is what like, talking to like, people that work with them like helps you with. So for instance, there's some advisors that want their students to publish okay, sorry, we run a quota system in my school. So we have like um 4 sessions in the year, but some other schools have like semester systems where you have like 3 semesters, I think, in the year. But anyways, like the advisors that want their students to like publish like every 3 months. Um, right. I mean, there are probably some research works that you could do in 3 months, really, but research like takes time, right? So this kind of professor that would just like, push you to publish half-baked results. Also like what's their funding situation if you're a grad student, right? Like, are they going to fund you or like until you finish, or do they not have funding and you probably have to like, like try to find funding or whatever. Um, so we've talked about like advisors and mentors. I would say that like so I mostly talked about things that like apply to like grad students. I'll say that like for like independent researchers that are seeking that want to go to grad school or that want to do research, one of the ways to seek mentors and to seek advisors is, through research communities. So like AI Saturdays, like Masakani, I think there's MLC, there are a couple of other, I think Cohort for AI has a research community. So there are lots of like communities that have, senior researchers, not even just senior, even junior researchers too can also mentor. That could help. Yeah, so usually like code mailing like usually works. But the truth is that like not everybody will reply. People are really busy, to be honest. Like professors especially like get like tons of emails every day from people that want to work with them. So like the fact that they're not replying you is not because they do not want to work with you. It's just like, overwhelming. But code mailing works, or joining research communities and, trying to join projects. So sometimes, some research communities, people would have like projects where they need like, people to join. And from that way, like, you can build research experience and learn from people. So we've talked about choosing advisors, mentors, we talked about like choosing research topics. So now let's talk about how to, transform ideas to publications. So yeah, not all ideas actually even go beyond the idea stage. A lot of ideas, do not, like, you just think of the idea and, you just know that like, yeah, it's not going to work. So you talk to your advisors. Yeah. So I have two advisors. Um, One of my advisors is like very selective. Both my advisors are hands off. One of my advisors is very senior. One she's senior, the other one is senior too. But so there are situations where like, I'm talking to one advisor about an idea and then like they really love the idea. And then you go to talk to the other advisor and they're like, oh no, we shouldn't work on this. And then I've had like, situations like this. Yeah. So some ideas would not leave. I mean, there's some cases where like, they say you shouldn't work on it, but you really believe in your idea and you still like pursue it and then you see good results. And there are sometimes when like, you would defy them and then, you will get bad results. But I guess the point is that like, yeah, there's some ideas that like, you have to decide. So decide like if they are worth your time. So for instance, like if you have an idea on like, modifying or building like a new architecture to train models, you want to beat like transformers. So think about like, okay, how do I even evaluate this method? Right, like how would yeah, sorry, I didn't make slides for this part, but it just came to mind to talk about it. Like how would I even evaluate this? Like if you to show that like a model actually beats like a state-of-the-art model like transformers, you have to pre-train, right? And to pre-train, you need compute, you need computational resources, you need lots of data. So can you really test that idea out? I think at some point in my PhD too, like I used to come up with like lots of ambitious ideas. Oh my God. Um, yeah, at some point I would even work on some and I'm just like, okay, this is going nowhere and I will just stop. And it's really good to not be emotionally attached to ideas that are very ambitious. It's not like you shouldn't work on them, but if there's no feasibility, so there's some ideas that in my mind I'm just like, okay, I'll keep this until I probably go do an internship in like, a company that has lots of resources. Right. So first of all, figure out how realistically would I evaluate this whatever solution I come up with. Right. Like, is it realistic? Is it something also think about like technical strengths or knowledge gaps. Like, do you even have like the knowledge or do you have like the technical know-how to, improve on stuff before you like, go ahead. And don't feel emotionally attached. If like, I mean, people give like ideas like, timelines, right? Okay, if I've worked on this for 2 months, if it doesn't work, then that's fine. I think I worked on a project for like a whole year, and honestly, at the end of the day, we got it accepted somewhere, but honestly, I wasn't even proud of the results. I was just like, yeah, this was just a waste of my time. I should have stopped working on this like 3 months, 3 months, after 3 months. But anyways, yeah. So let's talk about like, idea to publication. Um, so the very ideal perfect situation, honestly, like every grad student loves this. Everybody loves this. You have your problem, you have a solution that works. So you have your problem, you just come up with a solution on the fly, bam, and it just works. And then you just beat state of the art, bam, and you beat, and then why are you laughing? And then you just write your paper. So you have good results. You go and show your supervisor. They're like, oh yeah, let's just go and write the paper. And so you write the paper. After writing the paper, you just write the paper. You just submit also, bam, you get accepted. New rips, straight up. You go and present the work. And everybody's happy. Everybody goes on. You put it on your CV. It shows up on your Google Scholar. Yeah. But does it always work that way? No. It doesn't always work. Some people are, I mean, I don't know. Some people are that lucky though. Like yeah, I'm friends with like people that like, they just work on, I don't know how they do it. Yeah, maybe I'm just not like smart enough. But they just work on like they just come up with like brilliant ideas, like they work on these ideas and they submit them like, once and then it gets accepted. They even get like best paper awards and you're just like, oh, what am I doing wrong? But it doesn't always work this way. And it doesn't mean that like, you're a bad researcher if you don't have like this pathway. So the usual thing that happens is that you have a problem and you come up with a solution. It could be like the most naive solution, right? And it fails. Like you have like this very elegant solution, simple, or even complex, like you write a lot of maths and it fails. So you go back. So the beautiful thing about having a problem and not like the beautiful thing about starting from a problem and not starting from a solution is that like you just have your problem, you're like, okay, how do I solve this? Okay, I'm going to try this, I'm going to try it. But if you have a solution, you know, so you go back to your problem and then you're like, okay, how else can we solve this problem? Yeah, so you come up with like a new solution. And then you just beat state of the art by like 0.2 points. So that's like incremental, right? It's probably it could probably just be like you trained with like a very good random seed and that's why like you saw that. So like your results are not like significantly like they're not like statistically significant. Right? So you have to go back to your problem like, okay, what else can we do? So usually like this is how it happens sometimes. Sometimes people just have, I mean, I've had projects where like, I just know like what I'm going to do and then like I mean, along the way, you come up with like, better solutions, but like at least something works immediately. Or you come up with with a solution to a problem and it just works for a certain domain, doesn't generalize. So you go back, except you're just working on domain specific solutions. So you go back, okay, I want my solution to be very generic because I want people to use my method. And eventually you find something that works. And then this whole process I just involved just entails looking at existing solutions, trying to improve on top of them, working on building something novel, and you finally have something that works. And so you write the paper now. You have something that works. Okay, let's write the paper. So you write the paper and then you submit and they reject you. Like, okay, before they even reject you, you first of all face review two. There are things that like your whole work is shit, it's rubbish, like you shouldn't be working on this. So sometimes you have three reviewers and two reviewers are like, oh, this is so good. Like I should nominate this for a best paper award. And there's just one reviewer that's like, oh no, what are you even doing? This is rubbish. And sometimes in like, the first time you submit the paper, you might get accepted. This happens to a lot of people a lot of times. Um, but sometimes, honestly, like you probably have to like, go back to refine the paper. So if it gets rejected, you go back, like refine the paper, try to improve it, and probably submit to like, somewhere else or submit to the same conference. And then finally, you now get accepted. Right? And then you go and present your paper. So after acceptance, you have to let me talk a bit about writing a good paper before I talk about like, presenting. Yeah, I don't know how much time I have left. But I will try to like just speed up. Um, so writing a good paper is very important, trust me. Like honestly, if you work on the most elegant solution in this life and you don't write a good paper, nobody's going to cite you, nobody's going to use your work, nobody's going to understand anything that you do. So you need to write for your readers. Don't write for yourself. Don't write to make yourself happy. Write to make your readers happy. Identify like key contributions of your work. Be very clear and use like very concrete examples. Use very simple language. Don't complicate it with like unnecessary maths. Like I love my professors so much. Um, they like it when things are like really simplified. Like if you do not have to use an equation, do not use the equation. Yeah. Um, So explicitly state your exact idea. So some of this part actually is gotten from like some like I think I've linked in the references. Like a very good resource that one of my advisors created actually on how to write a good paper. So some of this just like me, like just rewarding things from like this portion exactly from like what he had written. So explicitly state your exact idea. Like don't beat around the bush. Don't like you don't want to put too much stress on your reader. So just say like the main idea of the paper is XYZ. And this should be at the beginning of your paper. You don't want people to start searching for like your idea, right? Like I mentioned, good ideas that are not easily understood equates a bad paper. Like if you have a very good idea and people don't understand it, like people wouldn't like build on it. They wouldn't use your work. Um, so this is typically how like a conference paper should be structured. And yeah, I mean this is all from Noah, and I really believe it. So typically this is an estimate of the number of people that would read your title. It's usually small, like lower than this, except you post on Twitter. So people will read your title. And sometimes if you have a very catchy title, then people will be like, interested in like, reading. For instance, if you have like a title that has something is X is all you need, then maybe people will like, find it like very catchy. Um, but how many people read the abstract? So abstract is usually like a summary, right? So like maybe like 100 people read the abstract, to be honest. Like from the title, they're like, okay, this is not my thing. So maybe a few people read it. Right. Your introduction, people want to know like, what you do. The problem really, like except I care about, I'm working in that area and I think you've done something elegant that I could point out from the abstracts, I probably wouldn't even like, go further, right? To even see how you solved it. Except I think it's most times people just like, go to the results, to be honest, and just see like, what they beat it of the art. Okay, they did not, okay, whatever. But conclusions, like a lot of people read conclusions because they also want to like so conclusion and your abstract is still like a summary. So usually it's very good to like, write these parts very well. So because if someone reads your abstract and they are still confused, they probably wouldn't even go into the introduction or even go to the rest of the paper. Um, yeah. So you want to like write like, very clearly. So understand your readers, and this helps you to tailor your content. What notion are they familiar with? What kind of terminology should you use? Whether to include like fine-grained details. Respect your reader. Do not overclaim or misrepresent results. Like don't misrepresent your results. Don't bore your reader. Like don't just be beating around the bush. Like just get straight to the point. Like it's a paper. Organize your writing. Yeah, don't make your reader work more than necessary. Like they're just reading your work. And also like don't be harsh about how you present things. Don't present things like, oh yeah, this is the de facto method that people should use. Because people have like ideologies and models and methods that they've tried that they really like. Some people like very traditional ML approaches to solving problems. Don't tell them and say, yeah, language models are the way. You must use language models or never, right? Be very respectful. So also like, questions that you should ask yourself when you're writing your paper. Are you introducing a new problem? Like, do you need to convince because there are some ideas that I was talking to somebody this morning about like a project I worked on before, and he was like, oh, this is magic. And I'm like, no, it's not magic. Like, it's clearly written. And I was explaining, and he was like, no, does it just work like that? So sometimes you need to convince people that like this is important and this works, right? So decide like if so sometimes like if you're um implementing like a new architecture, like something that's really ambitious, you actually need to convince people that this is important and that it works, and you have to show them that it works. I introduced a new technique. What are the benefits relative to alternative techniques? Be very honest about like, the implications and flaws of your work. Don't hide them. What's difficult to understand, right? Like if you need to like clearly state your algorithms, like what are the assumptions that people should have? Yeah, just clearly like, put it there. Tips for good writing: get started early, ask people for help, ask your mentors for help, ask your friends for help, ask your friends to read your paper, ask people that are not in your field to read your paper. This is what my advice us to do. Because I have like labs, I belong to labs that work on like very like diverse things. And usually my professor will say, okay, yeah, give somebody, that works on like, reasoning, or someone that works on video language models to read your paper and see if they understand it. Use very simple and direct language. Don't complicate things. Don't use like, Queen's English, really, like very simple. Communicate like very clearly. Yeah, okay. Yeah, now I think I know I'm speeding. So the process of submitting and publishing to the top CS conference. So if you want to submit very good work, quality work that you're proud of. Like not have big results. So usually like you submit like your paper, then people review the paper and then they give you feedback, and you need to write rebuttals. So rebuttals are just like, clarifying like questions in the minds of your reviewer. Sometimes they will ask you to like, run your experiments before they increase your, the score that they give you, blah, blah, blah. Remember that the review process is very random, honestly. It's very, very random. If your paper doesn't get accepted, it doesn't mean that your work is bad. It might just be some undergrad somewhere that reviewed your paper and does not know anything about your paper. Really. And this happens like a lot of times. And if your paper gets accepted, fine. It also doesn't mean that, oh, your paper is the best, really. It's a very random process. And resubmit, when you resubmit papers, like improve on it. Usually some venues would even ask you to add like your previous rebuttals and, explicitly state what improvements you had made, compared to like your previous work. Okay, I have like those two more things to cover. So presenting like your work. So yeah, so let's assume that you have submitted your paper and it has gotten accepted. So now you have to present your work. So sometimes you might have to present your work orally, to like an audience, like a very large audience, right? Or sometimes you might just like have to present a poster, do a poster session. So things that are important is like identify your audience. Um, strive to like, strive for clarity for your specific audience. Like, who are you talking to? Right? Like, make sure that like, you are, defining terminologies they can like relate to what you're saying. What kind of story are you trying to tell? Every sentence in your slide matters. Set up your problem very like people understand. Like the goal of you giving the talks for people to understand what you're trying to solve, even if they don't even know what method you're solving, convince them like that what you're trying to like your solution is or your problem is very important, right? So establish goals and assumptions. Show, don't tell. It's usually good to like, communicate with figures rather than text. Like show things visually. Like personally, I'm a very visual person, honestly. So it's like very easy for people to see what you've done rather than like, reading, okay. Yeah. So also end on a positive note, but always discuss implications of your work. Because there are always implications, right? It could be negative, it could be positive. So creative and effective poster. This is a poster of like some paper that were presented at ACL. I probably could just skim through this. But there are probably resources online on, how to do this. Use fewer words than you think. You don't need so many words because people don't want to be reading. They want to just see visually what is happening. Like in this poster, in this work, we're trying to show that we developed an algorithm that could encode like, text better across languages. Describe the problem, motivate the problem, why should the reader care about it? Explicitly state what your main idea and your insight is. Like be very visual and have a story your audience will want to hear, really. Because you want to grab people's attention. I think at ACL, one of my friends, she worked on a project that I think the project was for people to use like language models to have difficult to engage in like very difficult decisions. For instance, like if you want to engage in a difficult discussion with your friend, just using language models to help to like bootstrap the process, right? Like, tell you, what, so they kind of like developed a framework on how to do this, and they tested with like human annotators. And when she was presenting this at the poster, the title of her poster was How to Fight with Your Advisor or something. I can't remember. And like there's so like I took pictures like so many people in front of our poster just because it was catchy. Yeah. So sometimes these kind of things work. Really. Um yeah, okay, yes. Finally, I think yeah, I'm finally at the end. Yeah, sorry if I'm rushing. Just trying to meet time. So the highs and lows of research. Yeah, this part, yeah. So there are lots of highs. But there are also lots of lows. There are probably like more lows than highs, to be honest. So the support highs, things that like, people are usually excited about, like, constantly publishing papers every semester, getting like, every conference, you're publishing papers, publishing also in top conferences, right? People will like, respect you, people will cite your work, or winning best paper awards. These ones are good, I guess. But also there are also like cooler things really beyond, constantly publishing papers. Attending conferences is nice, really. and discussing your work with fellow, like with people, like, rubbing minds, rubbing ideas. It's like really awesome. Making consistent progress on your work, on your ideas, like it's awesome. Like the really cool things, like, just working on a problem and, coming up with solutions, like really cool. It's very rewarding. Like I love it so much. Coming up with exciting and impactful ideas, ambitious ideas, like it's such a high, like it's like high up there. Even if it doesn't reach, like, eventually like turn to a paper or turn to an award, it's really good. Or even collaborating, like working, like I'm super grateful for the people that I work with. I work with people that are like so supportive. Sometimes like I'm in a meeting and people are giving like ideas and stuff, and I go back and I'm like, oh yeah, I'm so blessed to have all of these people like to collaborate. So that's such a high for me, honestly. Like being, like having like really supportive advisors and supportive friends, people that I can, brainstorm with and stuff. Like these are things that I care about. But obviously, you should care about the other things. Like you should care about publishing papers because you're doing a PhD, right? Yeah, you want to get a job afterwards. You should care about winning paper awards. It's good, yeah. Recruiters would, be on your LinkedIn or whatever. But there's other things that like are really brilliant. Also seeing the impact of your work, really. Like we worked on this project last year, and like till today, the project on tokenization, like identifying flaws of tokenization in like language models like OpenAI's ChatGPT. Until today, like I randomly emailed somebody for something like very different, like this week. And like a professor that I have never talked to before, like I needed a favor from her. And then she emailed me and she was like, oh yeah, I'm going to do this for you. But by the way, like I saw this work, like, I spoke to Sam Altman about your work and you're asking them like if they're going to like chain tokenizer and open it like in their current model and so on. I'm like, okay, yeah, this was like work I had done like last year, I'd forgotten. So seeing the impact of your work, like seeing people talk about it, right, it's like such a high, like it's very good. So try to like work on impactful work. The laws, there are many laws, probably couldn't fit all of them on a slide. I can't remember a lot of them. So imposter syndrome, honestly, like imposter syndrome is something that, oh, sorry, I can see. Oh, okay. Yeah, I just wanted to know if, yes, I promise that I'm at the end. This is probably the last slide. So imposter syndrome is something that, you know, I constantly feel like I'm an imposter. Like, and honestly, like till you become a professor, till you reach the height of your career, you will always feel this way. Um, I mean, one of the reasons why, I probably feel this way is because I have a background that's not in computer science. I have a background in marine biology. Right. And honestly, like, I mean, that's like a very long story for another day of how I got to do computer science. But I guess the point is that the fact that I didn't have a CS background even makes it worse, right? Remember when I started research, you just see people talking and you're just like, oh, what are they saying? Or you see people talking about ideas, or you're in a meeting and people are just talking about stuff. Sometimes you actually even know, or like you're in a talk and someone comes to give a talk and you have like a very brilliant question. You're just like, oh, this question must be so stupid. Let me not ask it. And then just like one researcher that I respect just asks the same question. You're like, okay, I should have asked that. The imposter syndrome is not something that you should, worry about. Like it's fine if you feel like an imposter. It's fine. As long as it doesn't affect like your output. So you can feel it and you're just like, okay, yeah, I'm an imposter. Everybody's an imposter, whatever. To rejections, yeah. So this is, I mean, if you're a researcher, like rejections would like every day, like every second, like you get rejections. Papers will get rejected. Grants, fellowships, internships. Oh my God, internships. Ugh, yeah. Rejections, like would always like you'd always be you get I mean you get like some things accepted, right? But you also get rejections. Like projects will fail. Like you'd have lots of failed projects for different reasons. It's fine. Like all of these things happen. Financial hindrances. Oh, as a PhD student, yeah. You wouldn't be poor, but you will not be rich either. Like you just be okay. Um, which is also fine. But then you see your mates that are in industry, they are earning 10 times what you're earning, and you're just like, okay. But anyways, whatever. So these are some of the lows. Some people actually do not care about money. Like some people just, want to do research, whatever. But I mean, money is good, to be honest. At least like, sustain yourself. So final slide, I promise. Okay, sorry, I lied. second to the last slide. So how do I do all of this? I probably cannot fit all of this in a slide, but I celebrate the highs a lot. I told you about how, like, how I feel, joyful, like working with like brilliant people. We won an award sometime in I don't know, August, and like I, so excited. I celebrate these things. But when I get rejections, when when the lows come, like I focus on what I can control. And so this is one thing that has really helped me as a researcher. Even honestly, when I was applying to PhD programs, this is also something that like, helped me. I try to like I identify things that are within my control, which is as a researcher, what's within your control? Doing quality work, submitting to a paper. What can you not control? Whether your paper gets accepted. It's not in your hands at all, right? So I don't think about that side. When I finish a paper, I just submit it and that's it, right? So I don't think, I mean, it's hard I remember there are years where I consistently got rejections of papers and, I'll feel bad, but then it's fine, really. To get support from your advisors and friends, take needed break, like take breaks. I'm telling myself that to focus on delivering quality work. That's like very essential. So I always focus, like honestly, like yeah, block out the noise. For people that know me, know that like this is something I always say. There are a lot of things I see as noise personally, a lot of things I do not care about. Like honestly, like the only thing I care about is working, like doing quality work and like sometimes even to put out my work, I'm just like, okay, yeah, I want to work on the next thing. Like okay, I've done this, like let me just get to work on this. So there are lots of noise. You should put out your papers. You should celebrate yourself. Yeah, it's very good. Yeah, but like focus on what's important, which is like delivering good work. So if you delivered good work, if you've done good work, yeah, then put your paper out there. Let people like, but do not like major on the minor. Like you don't major on things that are like, are just like, excesses. Um, so finally, takeaways from my whole talk is that research is very exciting and truly rewarding. It's very frustrating, trust me. Like it's frustrating. Like research has made me cry like tears, to be honest. Has made me like, question, oh, like, why am I even doing a PhD, whatever. But it's very rewarding. Block out the noise, focus on doing quality work, seek out good mentors, collaborate with people, collaborate with people. Obviously, don't spread yourself too thin. Don't commit to 100 projects and not be able to deliver. It's better to work on one single project than to commit to 50 projects and not do anything significant. Yeah, so collaborate, but like, be sensible about it. Rest and take breaks. Find hobbies. Be humble. Yeah, be humble. Like, I don't know how to stress this enough. Like, there's nothing. Yeah, this is the last thing I'm going to say, right? And I know some people might disagree with me. I don't care. This is just my mantra. I don't really think people are special. I don't see myself as special personally. I don't think I'm more special than anybody here. I don't think I'm more special than Teju. I don't think there's anything that makes me special as a person. And this is not to say that like, like I'm not, excellent. That's not it. I'm just saying that like there's nothing that I have achieved or I think I have achieved that makes me better than the next person. So the fact that somebody gets a best paper award doesn't mean that like, they are better than me in quote. Or the fact that like, my paper gets accepted doesn't mean that like they're better. It might just be exposure, it might just be privilege, really. So check your privileges, be very humble, really. Don't be proud. Be proud of your work, but don't be arrogant, I guess. Yeah, that's all. Yeah, I have like references from like, where I got like, points for all of this stuff. So yeah. And yeah, thank you. Sorry I took
Oh
time.
my God, Oreva, that was amazing. That was amazing. Oh my goodness. Thank you so much. I know that Oreva is trying to be humble, but she also told you that we go way, way back. So I know a lot of story. And I just wanted to first say that she's super amazing in every way you want to think about. And our paper also won the Best Social Impact Award. It's not in her bio, but like she says less than what she do. And like I'm really proud of all of the work that you do, Oreva. And I'm very thankful that you have accepted to speak here. And Oreva is also part of AI Saturday Lagos. She's a co-organizer, and she another thing I'm extremely proud of your achievement is just how hard you work. People don't see it. But you have to understand that it must be insane amount of work to go from a bachelor's in marine science to a PhD in one of the top CS school in the United States. So that must be insane amount of work. So thank you so much for spending your time with us today, Oreva. And I'll open the floor up for questions.
Yeah. Thank you. Yeah, thank you so much. Yeah, Teju has, yeah, I don't want to cry here, so I'm just, yeah, I will just leave it at that. Yeah, I'm happy
Does
to answer
anyone
any
have any questions?
questions that anybody has. Yeah.
Okay. We'll wait for I'll pause for another 1 minute if anyone has questions. Otherwise, we will go into okay. There's a question. Josiah, please go ahead.
All right. Thank you for the question. I appreciate. So my question is, I guess at some point while you were talking, you said that if your paper get rejected, like for publishing, like you won't be able to resubmit. Am I correct? Did I hear that?
No. What I meant, no, I think what I said was that like you'll be able to resubmit, but it's usually important to improve on the paper. So like usually like when your papers get rejected, you'd have gotten reviews from like reviewers before. So what are the flaws that they identified? Like why did they think that like, why did they like, give like, give you like really like low score and then like work on this improvement. Sometimes it might just be bad luck with reviewers. Maybe the reviewer is not like experienced enough to review your paper. So in those cases, you can like it's fine to like resubmit again with like minimal improvements. But if reviewers like if like three reviewers have consistently like said that, oh yeah, this paper needs more work, then yeah, you should. But you can always resubmit yeah, as many times as you want until it gets accepted. So honestly, like sometimes people do not even like sometimes people like you submit a paper so much that like it gets rejected, like you just leave it on archive and just move on with your life, really. Or you submit to a journal or something, yeah.
Okay, so we'll take another question and then we will ease into panel and then you can ask more questions. I see many more in the chat. So the next person that said they have a question was Taiwo Abbas. Taiwo, please go ahead.
Okay, thank you very much. Thank you very much, Oreva, for the wonderful speech. My question, the first question is that when you talk about using simple English in the research paper, like won't it be like a medical work, like when it's very like when the English is like very, very simple? I don't know. And when you talk about putting equations in your papers, like if you don't need it, don't put it, or don't put too much equations. Well, I don't know, maybe it's my thought, but I think that they usually I don't know, maybe the people that accept papers, when you are presenting the paper, they should be like, I don't know, is it a must to have equations in your paper? Then the third, I want to code email the professor and I try to like check their work and I see that, oh, they've
so I heard the first two questions, but I can't hear the last one.
So Taro, how about we take the third question in chat? You're breaking really badly right now. But Oreva, can you go ahead, take a stab at the first two, and then we'll take the last one in the chat.
Right. Okay, I was muted. Yeah. So with like using simple words doesn't mean like, writing bad English, right? It just means that like you're using concepts that are very clear. You're not using like complex words. Like you're not going to like getting a thesaurus to look for synonyms, like complex synonyms of a word. So if you want to say So there are some like, you want to say like, we use this method and you say, oh, we utilize. I mean, utilize is still fine, really. But sometimes people use like very complex English to convey something that's like very simple. Like we did this in our work. Just say, don't like, say something that you say in 5 words, don't say it in like 20 words. You even have like limited like space anyways. So like just like be simple. That's what I meant by simple. So by be simple, like, and it doesn't make you look mediocre, to be honest. Like, I've had papers that I'm writing with my advisors, and then to me it's not even complex. Like it's very simple. My advisor is like, yeah, just like take this out, please. And like they write something that's like, like simple to understand. So it doesn't make you look mediocre, to be honest. Like, I'm not saying like you should write things that are not grammatically correct. It should be grammatically correct. It should be grammatically sound, but it should, be simple for people to understand. You don't want people to like be opening dictionaries to understand what you're saying in your paper. Like if I have to open dictionaries to even understand what someone said, like I will probably even get distracted. Yeah. So for equations, really, it's kind of dependent. People use equations to convey like methods, to convey algorithms, right? So there are situations where you don't need it, right? Some people use equations to make their papers look, so am I still here? Okay, yeah. Some people use equations to make their papers look, elegant. Yeah, I should probably stop sharing. To make their papers look really elegant or like, theoretically sound, even when they don't even need equations. Like I think there was this paper, honestly, it wasn't my fault. I think it was my first paper with my advisor. And I was writing like some equations and I had like 5 lines and my advisor just compressed it into one single equation. And I was like, oh, what is this guy trying to do? But you don't even have space in the first place. But there's sometimes where you need to like break things down. So you need to like, break things. Like for instance, if you're writing proofs, for instance, like some papers, there's sometimes you develop like, algorithms and you need to like, write proofs for those algorithms because reviewers will ask for them or to. So sometimes like, for this kind of situations, you need to like, write lots. Sometimes like some papers are like, just equations and stuff. My point is that like, do not use them when they are probably not necessary. Yeah, but if you need to convey something, if you think people would, and also like it depends on where you're submitting to also like it depends on the kind of audience, right? If you're submitting to like, an MMO conference, all of that, like who knows, like a reviewer might, be able to understand what you're doing better with this kind of thing. Yeah, so that's for the question. I hope I've answered your questions though, but yeah, I'm happy to.
Okay.
I think this.
Sorry, thank you so much, Oreva. In the interest of time, I would like us to thank Oreva so much for this wonderful presentation, the workshop talk. But Oreva is still with us until for the next 30 minutes, I suppose. But now we will transition into the panel discussion. And you can already scan that QR code to put all the questions that you have that you would still like to be answered there. And I would like to, without further ado, introduce our moderator for today's panel. His name is Shadrack Adeyemi, and he's a machine learning engineer at Voltrox HQ. Shadrack, the floor is yours, and you can share your screen now.
Hi, Tejumade, everybody. Can you confirm you can hear me clearly? Yeah, so Teju, I think you need to make me focus.
Can hear you.
Yeah, Teju, I think I need. Okay, thank you. Yeah. Okay. So also, can you confirm you can see my screen? Because, all right. So hi everybody. It's nice to be here. My name is Shadrack Adeyemi, and I'm a machine learning engineer at Voltrox HQ. I mean, most of us on the call already know what machine learning entails. Just basically building machines that can do what we can do as humans, but maybe faster, maybe better. But yeah, I'm happy to be here again, and happy to be in the midst of such great panelists. I mean, Orevaoghene, Intelligence Words is one of the OG co-organizers. It's nice to have everybody here. And then we'll have Joscha on the panel. So I'm going to be reading a very brief description of everybody on the panel. But we already know, or Tej already did justice to Oreva's presentation, or sorry, Oreva's bio. So we already know where Oreva is right now. But I'm going to be speaking on Joscha. Hi, Joscha. And I'll speak on Khadija. Khadija also is on the panel. So Khadija is a PhD student at Dublin City University, and she's a recipient of the SFI PhD funding at the Insights SFI Research Center for Data Analytics. Prior to this, she obtained a master's degree in mathematics from the African Institute for Mathematics Science, AIMS, in Ghana. And she joined Google and Facebook-sponsored African Masters of Machine Intelligence program at AIMS, Senegal. She's currently in the early stages of her PhD in computer applications with a research focus on multimodal image analysis. Khadija is also a co-founder of the Women's in Machine Learning and Data Science at CISPA, where she mentors young women interested in pursuing careers in AI. Yeah, so it's nice to have Khadija in our list. We also have Joscha, who is a co-organizer of AI Saturdays Lagos. And Joscha is a PhD researcher at CISPA Center for Information Security. He works on unsupervised interpretable methods for event sequence, such as pattern mining and causal discovery. So it's a lot to know about yourself, so I'm going to stop there for now. Like I said, you already know so much about Oreva. So, but I'm going to give everybody a minute or two to say a bit about themselves. So, start with Joscha. The floor is yours, Joscha.
Is it just me, or Shadrack's audio is not the clearest? Can everyone confirm the? Yeah.
Can you guys hear me?
Now it's a bit better.
Yeah, it's better now. It was muffled before.
Yes.
Thank you.
Oh,
this is much better. It's okay. It's much much better. Okay. Thank you. Keep going.
All right. So we're going to start with Joscha. Joscha, I want you to say a little bit about yourself besides what I said about you. And the very first question actually is for you. How did you choose your topic and all your supervisors? So the floor is yours, Joscha.
Hi everyone. Yeah, I'm Joscha, PhD student. Now in the process of wrapping up my PhD. Yeah. So how did I choose my topic and or supervisor? So for me, this was kind of, I did my master's thesis in the same group and then essentially continued on. So this is how I ended up with that supervisor. After my master's, I also interviewed with some other people. And then it's kind of about trying to figure out what they want to work on. And then, to be honest, it was also listening to one's gut a bit, like where you feel the relationship can work and where kind of feel like a bit unsure there. And then, yeah, going with your gut. It's not, in my opinion, not the worst decision. Yeah.
Thank you very much, Joscha. I think I also want to ask Khadija the same question. So, Khadija, how did you choose your topic?
Sorry, can you hear me?
Loud and clear.
Okay, so I think in my case, I didn't really get to choose my supervisor. So long story short, I think I kind of applied to a PhD here in Ireland, like a cohort-based PhD, where you really don't know the kind of topic you are working on or who is even supervising you in the beginning. So it's kind of like you come in the first year and like they train you. And then in your second year is when you actually start the PhD. So I applied to one of those. And then when that fell through, I just like received an email from my current supervisor saying that he had an opportunity and this was like what he works on. So like the topic or the supervisor wasn't really clear. And like the next meeting was when I got to meet 3 other people that would like be on my supervisory panel. And from there, I think I just saw that what they were doing was interesting. And yeah, that's how they became my supervisors. I didn't really get to choose or anything, but I ended up with the best.
Yeah, thank you, Khadija. So I mean, I think I like that there's another way or another way that you can arrive at a research topic, aside from the usual, or you have to do a search or go about it this way and that. So I like that Khadija's talking just from a supervisor. So we're going to move on to the next question. But before then, please, if you have questions for the panelists, please scan the QR code right in front of you, or you can just go to sliding.com and input this hashtag, and we will take your questions. Also, if you don't have a question, or if you don't have a question, you can vote for the questions that you think are most relevant, and then we'll take it up from there. So on to the next question. Okay, so this question is for Oreva. So hi Oreva. What specific gaps or needs in your field of research motivated your topic choice? And how did you validate the feasibility of your idea early on?
Okay, hi everyone. Yeah, I'm Oreva again. So this is an interesting question, because I think like throughout my PhD, I've kind of like worked on like different things. Like I think I've like moved a lot, but still like, still tied to like, one goal of developing language technologies that are useful for people. So currently I work on evaluating long form audio with language models that are trained on speech and text. Yeah, so trying to understand like how models can reason over long form audio. And how did I, decide to work on this? So I mean, I used to work on text a lot. Really, like a lot of my works were like on text. And I started to work on dialects. So dialects are like, variants of a language. So for instance, I speak Yoruba, for instance. I think I probably speak like the standard Yoruba, but then like there's like, Ijebu, like, there's like, there's Ijebu dialect, there's, Ife dialect or whatever. So I started to work on like, language technologies for this. And then I realized along the way that there are some dialects that have, non-standard varieties. Sorry, there's some dialects that have like, non-standard orthography. So it means that like they're orally spoken, but they can't be written. Right. So this got me interested in like working on speech. So that's what got me interested in working on speech. And I work on a project there.
Maybe I should come over there.
Sorry. Okay, yeah. So that's what got me working on speech. And I think along the line, I was kind of interested in like, I was thinking about, how to make speech language technologies useful for humans. And one of the things people do today is like something called alignment. So kind of like aligning like, model outputs to preferences of humans. So I was thinking of working on that. Yeah, sorry, this is a long story. I was thinking of working on that. And then we figured out that like, even if I worked on this, like on methods or techniques, there are no robust ways to evaluate like models that we train. So that's what got me into, working on what I currently work on. So there are lots of, open problems in, my field, NLP, speech, whatever, like tokenization, how to learn good representations, alignment, or whatever. But I think I kind of identified evaluation as something that people would care about in the future, particularly because like, there's lots of work on like text now. People want to work on audio and text or in the future. Well, like, how would they evaluate them? So I think I was just thinking, like, looking forward into the future and trying to figure out what people would care about. Yeah. And how did I validate the feasibility of my idea? Okay, this is like very simple. So I just looked at like existing like models that people have trained, looked at existing papers, looked at how like they evaluated them. And then you saw that, like, there are like clear gaps. Like there were things that they were not testing that they should be testing. And then, I tried to test these abilities and so that like, models cannot even like, perform certain tasks. And I'm like, oh yeah, this is very good. Yeah, and that got me excited.
Thank you very much, Oreva. That was a very good response. Again, if you please have questions for the panelists, please scan the barcode from you. And also let us kindly vote for the questions that I think are most relevant so we can pick from there. All right, so the next question. Hi, Joscha. So how did you discover your first idea that led to publication?
Was that for me? The audio is very muffled again.
Hi, Joscha. Yes, the question is for you. How did you
Yeah.
discover your first idea that led to publication?
Yeah. Again, this was my master's thesis. This essentially this topic. I worked on this master's thesis, and then when I started my PhD, we refined it towards a publication. So the first idea was not really mine. It came from my supervisor. I think most first ideas come from the supervisors, and then as you develop yourself into a more and more independent researcher, you come up with your own ideas. You start to know the field, what makes a good publication. So don't go into research thinking, okay, you need a brilliant idea that immediately leads to a publication. It's a learning process, and that's what is, in my opinion, also a PhD is for, to learn what makes a good paper. And the earlier you are, the more you're dependent on other people's idea, and more towards the end you get to your PhD, then you come up with more and more of your own ideas, and you develop a feeling what makes a good idea for a paper. Like it shouldn't be too big of an idea that you need 5 years to develop the thing. That's too much for a paper, but it should also not be just a small delta that, okay, we change some parameters, and I know. So there's a nice balance, and yeah.
Okay, thank you, Joscha. I apologize for my audio. I think I just had to go about it another way. I just want to confirm maybe it's much better from the audience.
It's okay. It is muffled, but we can kind of like make out. It's fine if there's something unclear, I can try to help.
Okay.
But keep going. Thank you.
All right, thank you very much, Khadija. All right, so Khadija, I have a question for you. The next is for you. So how did you deal with your first rejection, if you, had any at all? But how did you deal with it? Thank you, Khadija.
Yes, I did have a rejection. I think most researchers would have a rejection. And I think the short answer is I was sad. So I basically received the email at night, like around 1 a.m. or so, and I couldn't sleep until the next day. And then I went into the lab expecting my co-author to be moping around like I was, but surprisingly, he was like very calm. And I was like, what is happening? Did we not just get a rejection? Like, did I see a wrong email? So it was then that we actually sat down to like diagnose the problem. And what happened was when I saw the rejection, like it's in several stages. We basically have the strengths of the paper, the weaknesses of the paper, and then the decision, right? So that was when we sat down to like really look at it. Because when I saw it at first, I just went to the rejection, which was like a weak reject or something. I didn't really understand what it meant, but I just knew that it was a rejection. So after we sat down, and this was like my co-author and also like my PhD mentor, he kind of explained to me that let's look at everything bit by bit. So we basically just went through the strengths that were pointed out by the reviewers, and we also went through the weaknesses, which is basically things that they think is wrong with the paper or things that they think is not fixed enough for it to be like a quality research paper. I don't know if that makes sense, but that was basically it. And I got to realize that let me just take these weaknesses, work on them to better the paper, and then we submit it again. And one thing I want to point out is that if your paper is being rejected, it can mean so many things. Like one, it can mean that maybe the paper is just not in line with the conference. It doesn't really mean that it's a bad paper or something, but every conference has like their own ranking and the kind of papers that they want and the topics that they want. So you need to understand this before like actually submitting to the conference or the journal. And sometimes like every journal and every conference has different sets of rules as well. So for instance, I had a rejection as a journal, and this was just because one of the reviewers wanted me to change like a sentence. And to the journal, even if there is that kind of minor change, it's going to be rejected. So that's when you fix it and do now accept it. So that is just what you have to understand before like actually submitting. And yeah, I think that was how I dealt with my first rejection. It was a good experience.
Yeah, thank you very much, Khadija. Thank you very much, Khadija.
Can
Joscha, I think we'll have your hands raised.
Yeah. Just I want to quickly add that all the conferences have like acceptance rates, the big conferences between 20 and 30%. So it's totally normal that work gets rejected and most of the stuff gets submitted, gets rejected. And like it's just part of the process, I would say. And even the biggest names will, I don't know how many papers they get rejected, but they definitely get papers rejected. Doesn't mean the work is bad. It's just part of the process.
Yeah, thank you very much for that, Joscha. Joscha said it's part of the process, so it means if we get faced with rejection, we shouldn't give up, right? And we should keep at it. So, because of time, we're going to move at the faster pace. Please let's send in our questions. And I think I'm very much interested in this question, so I'm going to make the floor open to everybody on the panel to speak about this very question. So what emerging challenges in ML or AI research do you think will demand the most attention over the next 5 years? And how do you see research contributing to this future? I mean, we'd like to know this because this might also guide some of us that are trying to get into research to focus on some of the very important areas. So I'd like Oreva, Khadija, and Joscha to answer this question. Thank you.
Okay, yeah, I can go first. Yeah, this is a very good question. Yeah. So personally, I think that at least two things that I think are important that I care about first is developing like efficient model architectures so currently like a lot of like architectures that people use to train models now are very tailored to text, right? So you have like, subword tokenizers, whatever. They're very tailored to text, and when you apply them when you try to train such like models with such architectures on multiple modalities. So imagine you had a model and you have to train like text, you have to train on text, you have to train on audio, you have to train on images, right? Like how do you encode this? So with like text now, you can encode with like tokenizers, right? Like tokenization is just like segmenting your text. And this like, determines what kind of representation your model learns. So if you're using that, like how do you learn representations for audio or how do you learn representation for image? Like within like one single model. So obviously, like the way current architectures and current algorithms are built, they're not like very optimal for training multimodal models. And multimodal models are typically the future, right? You want like a model that's like human beings were inherently multimodal, right? Like we're talking now, like we can see, like you can hear me, like we're not like, texting. I'm not texting like, what I'm saying now, right? And then for models to be like, or for technology, for AI to be very impactful, then we have to like work on, models that can do multiple tasks across multiple modalities, right? So I think that like, thinking about rethinking architectures, like how to like train efficient architectures that learn like, representations across multimodalities jointly is very important. Besides like model training, one very critical thing I'm particular about is evaluation, like how to evaluate models. How to evaluate models in a very robust way. Like what are you evaluating? Like how to tie model evaluations to utility. Right. So for instance, people evaluate on this benchmark called MLU or like grade school maths. Interesting benchmarks that try to like teach us or like help us to understand how models are able to reason, but some of them are not like particularly useful to humans, right? So like sometimes it feels like there's a gap between like what the research community like wants to work on and what like will actually help humans. So like trying to like close that gap and to work on things that are important, like trying to like understand or evaluate like complex, abilities in models. So I think these are like, this is another like, research area that is very important. Yeah, I think that, and how do I see, okay, yeah, I think I don't know if I probably answered the question, right? So like, rethinking model architectures and rethinking ways to evaluate models. Yeah. And yeah, sorry if my answers are just biased towards like NLP and all of that.
It's fine, Oreva. Thank you very much. Khadija, you can go next.
Okay, I think I would come in with a computer vision perspective. So moving forward, I think that's one challenge that might emerge is like the precision of object detection algorithms, which is where I work in. Like there is a lot of challenges currently with using just like traditional computer vision algorithms. Like even though the yellow versions and other object detectors are like really good, there is still like some aspects of motion blur which affects this traditional algorithms. So what I work on currently is in multimodal computer vision. So aside just the images, we use data from event cameras, which are practically like sensors, which we use in addition to the images to be able to train like robust algorithms. So I think the way I see my research contributing to solving this challenge, especially in motion blur, is that with event cameras, like there is a lot of precision. So the data doesn't come out in the form of frames or like images like we know, but it comes out as a stream of data points where like if there is a change, then there is like an output. And if there is no change in like intensity, then there is no output. So because of these properties, like it makes it very easier to use and help solve the motion blur problem. And I think that in the next 5 to 10 years, event-based vision is going to become so popular and most people will look at it as another alternative. And just to end with one other way an events-based camera would like contribute to this field is in terms of like scalability and energy efficiency. Like it consumes very low energy, so it's easier to use this as compared to like traditional cameras, especially in like, let's say, applications like self-driving cars. Like it has low latency, which can really help in like applications like VR and all that. So yeah, that is what I work on currently, and that is how I think it can contribute to ML AI research.
Thank you very much, Khadija. Joscha, the floor is yours.
Yeah, I think this is a very, very hard question, especially if we focus on 10 years. Just thinking back 10 years, I don't think anyone would have predicted where we are right now. So 10 years, I think, is a long time in machine learning research. And who knows where we are in 10 years. But I think right now going forward is also interesting is building understanding how models work and what they look at. And essentially, can we explain to you, domain experts, what's actually going on in a model? And I think this is especially relevant to build trust in, let's say, medical domains. And like, okay, if our chatbot says something and we just use it for fun to chatting, maybe not that important. If you use medical things, very important. If you use it for just also information retrieval, we want to know what is the model is looking at, how it derives at their predictions. So we can trust these models a bit more. I think this is a direction that needs more work in the future.
Thank you very much, Joscha. Thank you, Oreva. Thank you, Khadija. Because I'm still having issues in my audio, I am going to step aside for Teju to take the questions from Slido. But thank you very much, guys, for having me. It's a pleasure to have handled the panel session. So I leave the floor for Teju now. Thank you, guys.
Thanks a lot, everyone. So we have a couple of questions on Slido, and thanks for the wonderful moderation, Shadrack. I'm sorry about the audio. I know it can be a little bit annoying, but there's nothing anyone can do about it. Thank you so much. So on the Slido, we have a couple of upvoted questions, and one of the most popular question here is that how did Oreva transition from a bachelor's in marine science to a PhD in computer science?
Oh my God, how did she do that? Jeez. Somebody asked me the same question today. Okay, yeah, I'm trying to figure out what the short version of the story is. Yeah, the answer is actually AI Saturdays. Actually, if I wanted to like, give like a very short answer, it's actually AI Saturdays. So I started doing AI or like learning AI with AI Saturdays. So I was in Unilag in 20, I don't know, I was in Unilag in 20, I don't know, up until 2018. Can't remember when AI Saturday started. But yeah, so I think, so this particular day, I'll just give a very short story about I actually found out about AI Saturdays. I've always wanted to do things outside of marine sciences. I'd always wanted to do so. And I honestly, like, I really even cared that I was studying marine science then. Like, it was just like I had finished high school and I had to go to school. That was it. Like, I didn't know what I wanted to do. So I was just there studying marine sciences, whatever. And then this particular day, I was just on Twitter. So then I used to follow a lot of like, tech bros and tech sissies on Twitter. And someone just tweeted, I don't know, I can't remember his name, Eskid, I think that's his name. Yeah, and he just tweeted something about, I think he retweeted like Teju's like, post. Yeah, so this is starting. And honestly, I didn't even know what AI was then. I was just like, oh, what's that? I think I always wanted to do something in like IoT, where I was like, okay, this sounds like robotics. So this sounds like I will be touching robots or whatever. I'm like, okay, let me just go. Let me just register. And so so I saw this like midnight, like 1 a.m. And I was like, okay, I'm just gonna go try my luck. If I don't like it, I will just stop going. And I went the first day and it was so intimidating. Like, everybody is like, oh yeah, I'm a computer science student, blah, blah, blah. Oh, I've read this. I've read. And I was just like, honestly, like that day, like I didn't even understand what anybody was saying that day. And I went home, I was like, hey, what's this? I probably should not go again. But I kept on going, even if nothing made sense. So I kept on going and kept on going and kept on going. And honestly, nothing made sense for like lots of months. And along the line, things started to make sense. So I had to like do a lot of like upskilling myself. I'll be very honest with you. So ASS was good with like, introducing like the basics, but I had to do lots of upskilling. Like I had to, oh my God, I had to learn how to code. I had to like study maths. And it was very crazy because I didn't like I studied marine sciences, like water, fishes, really. So I think I only took one math course throughout my stay in lag, and it was just a very simple, like I had an A, so it was really simple for me to have had an A in that course. It was really simple, like very simple math. So I had to like learn maths. And the annoying thing about like my learning process then was like I forget things a lot. So I would learn something today and I will forget it. Like I would always forget. Like I always had to like, keep going back to things. And then I got into an internship at InstaDeep through a hackathon that AS Saturdays organized. I don't even know how I was in that. Honestly, I wasn't supposed to be there that day. Like so many things just happened. I look at my story and I'm just like, everything. That's why I say that, like, I don't think I'm special. Like a lot of things are just based on luck. I should have been somewhere on that day, like on the day of the hackathon. Like I had like somewhere to go, actually, somewhere that I deemed more important, to be honest. And I was just in the hackathon there, and then, the winners of the hackathon got like, an internship at InstaDeep. So I started doing my internship at InstaDeep. Trust me, it was rough, honestly, because I think I was writing my final exams I didn't even care then. Like honestly, like, I didn't care about my final exams. I knew that I wasn't going to fail. I was going to pass with like, a 2-1. I think I finished with like 3.8 or so out of 5. I was like, okay, yeah, see, I don't even care about this. So I started with InstaDeep doing an internship. It was very rough, trust me, like starting out. Because like you're in a company with like people from like, other places that are so smart, people that have like masters, and you're just there, you're like just doing your small projects generally. And after the internship, I got a full-time role there and started to I can't even remember what we're working on, but eventually, I think I started to develop interest. We worked on like some project on like machine translation for pidgin. Yeah, with like one of my colleagues, and somehow we presented that in Indaba, and people like really liked it. And then for some reason, I think so. Instead of then like company I was working with, we got like a deal to like I think like some partnerships with like some company that was like building like cancer vaccines, and I was put on this project. It was like my first big project. Yeah, and like okay, yeah, I can't mess this up because there are like lots of like brilliant people on this team. So that really pushed me a lot. I think it was actually on that project that I learned like I mean I knew how to code, but like I learned lots of like things around like software engineering, like how to reproduce people's papers, how to like, like you have a problem you want to solve and you have to like, come up with a solution. You have to implement a solution from an existing paper. I remember there was this paper, I still remember the name of the paper was called Control VAE. I don't even know if their code was available. I think I had to like implement it also from scratch and it was like, really, bad. So from there, I gained experience with like, working on research products, I guess. And along the line, I started developing interest in low resource languages. Then I reached out to Sarah Hooker at some point. She mentored me on, so you see all of this is just luck, like nothing from my side. I reached out to Sarah Hooker and then she mentored me on some projects. And then my interest began, like just continued to develop. I was working, it was insane. Like I was working like crazy, to be honest. Like working on myself, that's it, like upskilling. And then sorry, the story is getting to an end. It's always a long story to tell. And then so I worked with like Sarah on like a paper, Sarah Hooker on a paper, and the paper led to a publication. And so then I was thinking about like, what next should I do? I think I want to work on research full time. Besides working on research full time, I actually wanted to just go to grad school, to be honest, because I just wanted a computer science degree. I'm like, nobody will respect me with this BSc in marine sciences. Like, if I even had a BSc in computer science, maybe that would have made them like nobody will respect me, or and I'm like, okay, I just want to go to grad school. So the first year I applied to like, grad like master's programs in Canada, and I got rejections, like all rejections. And I mean, I felt bad, but I was like, whatever. And then the next year I was like, And honestly, like nothing really changed between the first and the second year I applied. Okay, maybe I had the paper publication, but whatever. And then next year I was like, okay, yeah, I want to apply to masters. The first year I was applying to Canada, I was like, okay, yeah, maybe I should also apply to the US, apply for PhD programs. Honestly, I didn't even think I was going to get in. So it was a lot of work, to be honest. Like I was reaching out to professors. Oh yeah, I think probably reached out to like 60 professors. A lot of them will not reply you. Some of them will tell you like, and honestly, the reason I was reaching out to professors was because I knew what was within my control. I knew what I had. I knew that I didn't have like, a degree in computer science. I knew that, I had like limited work experience or whatever. So anyways, I applied to PhD programs. And even so, the current school I'm at, so University of Washington, I didn't plan to go there because I was like, all the professors, so I mean, and this is not even like you bragging, like, so UW is like one of the best schools for NLP. It's like a very top, like it's a very good school. Like professors are like really, high up there. And I was looking at professor, I'm like, yeah, this is like too big for me. I don't think I can reach it. So I was not going to apply here. And then I got a fee waiver, and I'm like, okay, let me just use the fee waiver to apply. And then I applied, and my current advisors reached out to me sometime like February. I was like, so my current advisor, I followed him like on Twitter, like, previously, and I knew all of his work. And that day I saw like the email. I'm like, okay, am I seeing clearly? I remember like telling my brother was like, oh no, it's me. I mean, yeah, and all of that. And I had an interview with them, and they really like I really vibed with them. Yeah, and then I got offers in other places. One of the reasons why I decided to work with them was because I really loved what they wanted, like what we're going to work on. I love their vibe, and I just loved UW in general. But yeah, that's the short to honestly. I think that's like the whole like how it all went. So I think I mean the last thing I just want to say is that so like I mean it seems like it was like a very smooth path, but trust me, like it's even until now it's not that smooth. It's not smooth. Yeah.
Oh my God, thank you so much. I know you were not prepared to go into that today. Thanks for sharing. And I just wanted to say that like Oreva is doing such a great job throwing accolades, which is great. But again, what I think you should hold on the most to is how much work she
Oreva,
also
can I
has
add,
put
please,
in.
Dr. Isimeto?
Sorry, Dr. Isimeto,
Yeah, can I
yeah,
add to
could.
this? Oreva came to me to ask for reference letter. I told her to write everything. I remember she came to me. And then in the reference letter, she wrote a lot about, I had to testify how Oreva was good, how she was one of the facilitators at AI6, and then how she worked at Instadep. All her experiences were there. And I wrote and I asserted that she was really good. So Oreva, congratulations.
Thank you so much, Dr. Isimeto. Dr. Isimeto is also someone
Thank
that
you
has
so
been
much,
a
Doc.
huge part of the
Oreva,
community.
congratulations.
And and she has been part of the community, and she's doing such a great job, and we're very, very lucky to also have you join us for the research cohort. So I think we are really about we're not doing so well with the time today, but I guess we will cut out on the interactive session, and maybe we can just quickly take the last question from the panel, and I invite Joscha, actually, if you can talk a bit about this question that they asked: do we always have to beat the state of the art through our research? What if we just want to apply existing approaches in different ways? Is that research worthy?
So I would say you don't have to always beat the state of the art. You just have to write an interesting paper that reviewers and meta-reviewers will like. So in a way, you're always telling a story when you write a paper. And if you just apply existing methods in a lot of data sets, then it might be a benchmark or a survey paper. They exist and they can be very helpful to the research community. We'll just give a good overview of what exists. And there's no list what you have to do to write a paper. So when you write a paper, you submit it to a conference and then usually get between 3 and 5 reviews. And these are other researchers that could be professors, could be some student. It's essentially up to the conference who they invite to review. And then they write their opinion, and with a recommendation, going from reject to accept. And then some meta reviewer decides what to accept or reject which papers. And so you don't have to be the state of the art, but you have to write an interesting paper that people think is worthy being presented at the conference. And what you discuss in these papers, what you think interesting, and hopefully the research community think is interesting. So no, you don't have to be the state of the art. But if you don't be the state of the art, then you should position your paper as a survey paper or a benchmark paper. I'm going to say it's easier to write a paper where you just say, okay, we are better. We are this much better than the state of the art. That's an easier story to tell than okay, under these settings, these are better, and these settings, these are better. Then it gets more nuanced, and reviewers sometimes don't spend too much time reviewing. So if your line is the highest or your bars are the highest, that's makes it easier for them to accept your paper. And the other way around, if you're somewhere in the middle, it makes it easier for them to reject your paper. It's not quite how it should be, but it's part of the reality how reviews what happens. Yeah. So in short, no, but depends what kind of paper you want to write.
Thank you so much, Joscha. And lastly, I will allow Khadija to maybe say any closing words, anything that comes to mind at all.
Sorry, I think the other panelists have said it all. I don't really have any closing words. But one thing I would say just on the paper thing, I think my first ever paper wasn't like, I didn't have to be like the benchmark or something. In my paper, I actually showed that like the benchmark or the paper I was trying to replicate actually had better results than what I did. But we just showed it in a way that we sort of had like different ways of doing things. So if you could also show that your approach is more feasible and like more scalable than the benchmark or the paper that you are trying to beat, the state of the art paper, I think that makes more sense for people to go like, even though that presents like the best results, this way of doing it uses like less competition, less like resources and all of that. And yeah, I think that could also work. Another thing you can do is to like title it as like an evaluation paper. So that's like Joscha said, reviewers would know that you are not trying to be the state of the art, or you are not presenting like any like novelty, but you're actually just trying to show like other ways of doing this. And it might work out that way. So I guess that is my closing remarks.
Well, thank you so much to you, Oreva, Khadija, and Joscha, and to our wonderful moderator, Shadrack. This has been wonderful and excellent, and I've learned so much. I've noted some things down. I would always go back to Oreva's slides to remind myself when I go into these lows and, add the high. And hopefully maybe in the future, I get to collaborate with Oreva as well, and we can bring it some magic. I'm just putting it out there in the universe. You heard it first on AST Lagos research cohort. All right, so everyone,
Oreva,
please give
Oreva,
another
you're so
round of applause.
beautiful.
And sorry, Dr. Simito, if you could please don't interrupt in that way, it would be great. We are live streaming right now. Thank you so much. Thank you so much, everyone, for staying until almost the end. Right now, we would go into a small pause for you to fill the attendance form. We had also prepared an interactive 10-minute interactive session, but I understand we are 6 minutes out. So I will go into this, but it's totally understandable if you need to head out. But the whole idea of the interactive session is that, this is supposed to be pausing for 1 minute, by the way. Let's pause for 1 minute. Okay, welcome back, everyone. So I know we have 4 minutes to the official end of this session. So I'm going to tell you what it's about, and we will end the live stream at that, and tell you about what you should expect next week. So the whole idea is that we want to create a breakout room for the different papers that we will be hearing more about next week. So currently we have 8 presenters for the AST Lagos Research Cohort 2, but right now on my slides I would have 7 papers because we just confirmed the last presenter. So if you go to this, if you scan this schedule, you would see the paper list, and the goal of this small group discussion is that you get to meet one another in small groups. You quickly have like a bird's eye view of the paper by reading the intro, the title of the paper, the abstracts, just to get a gist of it. What is the essence of this paper? Can you tell it from the abstract? This is the only question you should keep in mind as you're looking at that particular paper. So you have the opportunity to join any of the 7 breakout rooms I'm about to create, and each of these breakout rooms will be looking at the different papers. So for example, breakout room 1 will be looking at the exposure diffusion, learning to expose for low light image enhancement paper, while breakout room 6 will be looking at automated spinal MRI labeling from reports using a large language model. So you can just cherry pick which of this you want to go into, and you can find this breakout room from like on your icon. Once I create it, you would see like a breakout room, and then you can choose any of the breakout room. Let's say, for example, you choose breakout room 1, you click on join, and then you can, once you join the breakout room, you'll see yourself inside there. You can also leave when you want to leave, and so on. So I will stay on the main room. If you need any help, you can always call my attention. But I'll let you go into the various breakout room for 10 minutes. For those of us that still have 10 minutes and they want to get a practice at this, and for the rest of us that unfortunately cannot stay for more than this hour, that's understandable. We really would like to thank you for spending your afternoon, your morning, sorry, your Saturday morning or afternoon or evening, wherever you are with us. And we hope that you have gained something from today's session, and hope to see you next week. So yeah, without further ado, please please join the breakout rooms and talk for 10 minutes, and then you come back. After 10 minutes, I'm going to close the breakout room and we can discuss about the paper that you were looking at. Does that make sense to everyone? Yes, no, yes, no. Okay, I know I sped through that, but do you have any question before I create the sessions? Okay, I don't hear anything, any feedback from anyone. Can everyone still hear me? I hope I've not been talking to myself. Okay, great. Okay, thank you. All right. So someone asked if we should share the paper link. I'm about to do that. Let me copy paste it into the chat. Oh, good. Okay, so here are the paper links. You can directly click on the paper and to read more about them. And yeah, see you in 10 minutes.
Have you opened the breakout rooms?
I think you're muted.
Are we in a breakout room?
Oh, sorry. I just opened the breakout, so apologies. Now it's open. You can go there. You have to go to where you want to go to. So you have. I did not automatically assign people. So just choose any one of the papers and go there, please. If you're not going to any session, I'll just put you in sessions. I shouldn't be seeing anyone on the main session right now for the next 10 minutes, 9 minutes. So if you don't go, I'll put you there.
Yeah, sorry. I'm
Sorry.
trying to find out how I will get there. I can't really see the option.
Ah, okay.
can
So which one do you want to go? Which breakout room do you want to go to? I can put you there also.
Okay. Sorry, which of the paper? You mentioned quite a number of them,
Yeah.
but
Yeah, which of the paper would you like to go to? I can go back. So we have so here are the papers that we have. So we have these 7 papers right now.
okay. Yeah. Okay.
Which one would you like to go to?
Okay, I think 4. 4 will be
Four,
okay. Yeah.
okay. I'll put you in 4 now.
Okay. Thank you.
So, Toyiba, are you also experiencing challenge with joining? I can help you out if you would like. Just tell me which one you want to join and I can put you there. Bolan, would you like to join any of this? Anyone? Any of the paper? No one is speaking in room 5. I think the whole point is that Silas is asking. So I think you just need to read the the abstract of the paper and chat to one another. I don't think Silas can hear me, but let's see. Room 5. I'll do a broadcast to all the rooms. Hi everyone. I think this should be audible in all the rooms. I just wanted to say that if there is none of the presenters are there in your room to help guide the conversation, any one of you could do that. All you need to do is click on the paper for that particular room, look at the name of the paper, what is it about, look at the abstract, maybe the conclusion, and so on. So the task today is very simple. I just want you to come back to the main session to tell us about what the gist of the paper is. What is it about? What are they trying to do? One question. Okay, thank you everyone. See you in about 5 minutes. Hi, everyone. You have 2 more minutes before the end of the breakout session. Okay, closing our rooms, and we should be having everyone back in the main session right now, right about now, in the next 60 seconds. Hello. People should be back soon. There's a countdown. Oh yeah, now people are joining back. Yay, I see the numbers growing. Welcome back, everyone. How was your experience? Our very first breakout session at AIS at the Lakers. Woohoo! Can everyone hear me? I hear a feedback. I'm not sure from who's. Okay, this is great. Okay, so welcome back, everyone. How was it? I hope you had a fruitful discussion. And so for the next maybe a few minutes, I want us to say like one thing, like one sentence summary of the different papers that we interacted with. And I would go chronologically. The first one is the exposure diffusion. Was anyone in the breakout session for the exposure diffusion and they want to share what is the paper about, apart from the title, anyway, in their own words?
So I think it was just I and Joscha that was in the breakout room. And
Okay.
so basically what this the problem they intend to solve is to brighten dark photos. So usually the previous method they've been using, just use straightforward neural network, but they add issue of it's not being able to consider the ranges of the details and textures of the lightning, of the different lightning. So for an image where a particular part is being exposed a little, by the time the model is being applied to there's an overexposure. So this their method now is just they apply it now to create a balance in the results, so that a part of the image where is more exposed before don't get overexposed. So I think that's just what is being
Wow,
so.
thanks a lot for Thank you for the summary. That was great. Okay, so now we do another speed through. We will be hearing more about this paper, by the way, next week. So, so the next paper is solving Olympiad geometry without human demonstration. We need a volunteer, please. Someone to give us a gist of it. What are they doing? Anyone? Was there anyone in this breakout room too? Okay.
Okay.
Seems.
Since no
All right, thank you.
I'm the presenter, and so basically, what we spoke about is alpha geometry is a computer program that was written for improving math reasoning in large language models. There are different ways to do it, as I've said before. But alpha geometry employs neurosymbolic AI, and the neurosymbolic meta system, let me put it like that. And what they basically did is, they found math problems, geometry problems from math Olympiad. Olympiad is like one of the biggest math competitions in the world, and they try to solve these problems without relying on human solutions, basically. So what they did is they created. First of all, sorry, um, what they did is, instead of learning from like human examples and all those kind of things, they created a synthetic geometry problem with its solution. Then they used this data to train the model and help it guide its reasoning process in constructing proofs for complex problems. And this it's there's a lot of back and forth between the symbolic system and the neural network. And at the end of the day, they end up making like constructions, additional points or lines there and here and there to solve this problem, like mimicking the way humans would solve a normal geometry problem. And the results were quite impressive. They were able to solve about 25 out of like 30 recent Math Olympiad problems. And also, they were also able to solve a long-standing problem that has not been solved before. So that's it. That's just it.
Well, thank you so much. Wow, this is amazing. Again, we'll be hearing more about it next week. So thank you, Stella. And we will really have to speed through the rest right now because I want us to finish at most by 12:30. So please, if you can, please keep it very short. And the next paper we want to get the gist of is the ADD-NET, an effective deep learning model for early detection of Alzheimer's diseases in MRI scan. Does anyone want to tell us? Someone on the breakout room. Go ahead.
Sorry, yeah, I can go. So, yeah, so like the paper says, ADD-NET. So what the paper is trying to do is basically there's something called Alzheimer's disease, which is AD, which they refer to as AD, and it's a brain disorder, usually marked by dementia, and primarily affects people that are over 40. Also, it's incurable. So usually it's diagnosed through manual evaluation of the patient's MRI scan. And what the paper is trying to do is to propose or build a convolutional, or let's say a deep neural network that can detect AD, and they do that successfully. So I think that's like a summary.
Thank you so much. That's perfect, Zainab. So the next paper is the incentive-aware federated learning with training time model rewards. Anyone from the breakout room 4 that wants to take a stab at this?
I think I can try.
Thank you so.
So federated learning is a machine learning model that allows multiple people or groups or labs to train a model together without sharing their data. So what this paper is about is they have this algorithm and they are testing it, benchmarking it against several other algorithms that has been tried previously. And they were able to realize that their own new algorithm is much better than whatever existed before. And they had like several benchmarks for how this algorithm works in the industry. So the entire idea is it allows for collaboration now, and there is easier way to be able to train models and bring data to be able to train models without sharing data amongst the different labs that are going to be contributing to that research or to that project.
Thank you so much, Rufai. That was great. So the next paper is reinforcement learning with A-star and a deep heuristics. Do we have anyone from Breakhouse Room 5 that wants to help summarize this paper?
Yes. So I was the presenter. So this paper is combining two algorithms. So that's number one, using A-star, which is a path-finding algorithm, and deep neural network heuristic. So heuristic is just like having leader rules, like shortcut rules for getting something done. So this paper was like implemented for a driving simulation data. So most of the time, this the heuristic is not really adaptive. Like, what if the autonomous vehicle find itself in a very complex situation or a situation that it does not have an idea of what to do, even though they are laid down rules. So they are trying to make something that is more efficient and that can adapt and that can work real time. So the name of the algorithm they used after combining both of them was called Aleph star. This symbol that looks like an N with a star, so it's called Aleph star. So this paper talks about combining A star and deep neural network for reinforcement learning. So that's a summary of it.
Thank you so much, Desire. So the next paper, the sixth one, is the automated spinal MRI labeling from reports using a large language model. Do we have anyone in the room that wants to tell us about this?
I think I can give it a try.
Thank you.
Yes, so the paper is, trying to solve the problem of manually labeling medical images for training purposes. This is a very expensive and slow process, and there's always a limit on the size of the data sets. And the approach they are using is they're automating the extraction of condition labels from the reports. And then they try to simplify this process by using a large language model to automatically read the radiology reports and then identify 5 spinal conditions. That's cancer, stenosis, spondylolisthesis. They're difficult words for me, but 5 of those conditions. The automation will reduce the need for manual labeling by experts and also allow for generation of larger data sets for training machine learning models. So the authors developed a method to use LLMs, and they tested 2 open source LLMs, Zephyr and Llama, to summarize each report with a specific condition in mind. Then they create a yes or no label to indicate whether the condition was present. And the result they have is that the automated labeling performed as well, or in some cases better than human expert label data when used to train the classifiers. And for some of the conditions, the system's accuracy was comparable, or in some cases exceeded those manually labeled, basically. And this is yeah, this would reduce cost basically when you have this system in place, and then it will make it valuable for like having more data to do with.
So thank you so much, Isaac. I think you like went too much into detail. You don't want people to come next week. I'm just joking. You did amazing. So if you want to learn more about the papers that we've just given you a taste of, you should definitely come to next week's presentation that our presenters will be given. Isaac's paper is not here, but it's also very exciting. We'll update the GitHub soon. So the last one for today is modeling tabular data using conditional GAN. Do we have anyone that wants to talk about this paper? Okay, please go ahead, please.
Yeah, hi, my name is Victor. I think Peace shared the link I used to join. So now I'm Peace automatically. All right, so yeah, essentially this paper was talking about modeling tabular data with GANs. Usually, when we want to model tabular data, sometimes we have to balance out the data. We use, tools like SMOT and several other, popular statistical algorithms. But this paper then is trying to say, since we have problems with, continuous data and trying to see how we can replicate that, can we use, GANs to as a better way of generating synthetic data that we can then use to balance that tabular data. So it's a very interesting concept, and they try to benchmark their model, which they developed called CityGAN, with several other GANs, and it seems to outperform several of all those other existing frameworks. So yeah, very interesting and very cool paper.
Oh my God. Thank you so much, Victor, for that. And then thank you so very much, everyone. Oh my God, you're champions for staying until the end of the second week of AI at the Lagos Research Cohort. And I want to thank our speakers again. You are the champion of today. We would not have had such an amazing time without you and our moderators and all of our presenters who have joined the call to share more about their talk. And next week, we would not be having any workshop, and it's only going to be solely presentation based. So come on board, and we hope to see you next week. If you have any question, please reach out to us on Discord, and see you next time. Thanks, everyone. That's the end of the second week. Bye-bye.
Bye, everyone. Thank you for joining.
Yeah, please, Oreva, send us your slides. We need the slide, today's slide. Very good. Thank you.
Thank you.
Sorry, I'm going to do that. I mentioned it in chat. We will share it. We will share all the resources. Actually, keep an eye on the GitHub page because the slides will be there.